Hello and welcome to part 6 of our course, Getting Started as an Organisation on AWS, a guide to the boring bits that no one wants to do. In this part, the 6th part of the series, we'll be actually doing something on AWS, as in we'll be creating a workload account, and in this case we'll be deploying WordPress. Okay, so far what we've done is we've created and secured an AWS account. That was done in part 1. We also went through the hows and whys of using multiple AWS accounts as one AWS environment. We went through that in part 2 of the course. We also demonstrated how to grant access to AWS and third-party apps through a single sign-on portal. We went through that in part 4. And we also explained how to provide desktop and mail services to internal users managed through a self-hosted Active Directory. That was part 5. So what do we have now? Well, we have the ability to manage an organisation and add multiple real people to contribute to our AWS environment. We also have the ability to provide technical products such as like a desktop and mailbox, third-party apps to users who have an email address that we manage under our domain name. So now you want to actually use AWS. You want to run some sort of workloads, right? So it may be custom development, or it may be third-party software you're installing and managing yourself. It could be WordPress, which is what we're doing in this, what I'm demonstrating in this part of the course, but it could be anything really. So now you have the backbone to do that. Now it would be a shame to cut the course short and not actually do something valuable with AWS and deliver value to our imaginary end users. So what we're going to do in this course is we're going to build a workloads account for running WordPress. So we want to build an AWS, right? We want to deploy some sort of workload. So it could be installed, as I mentioned just then, we could install some sort of third-party software or software we developed ourselves. Different types of workloads, right? So we could be running database solutions, analytics solutions, AI or machine learning solutions, or we could just be deploying our web applications or our custom applications to AWS. So we could be using AWS Lambda, ECS, EC2, different types of resources, right? This is what our engineers will build, your engineers will build, or it could be you building and deploying to AWS. So the workloads will split into different accounts, workload accounts, okay, and they'll sit within the workloads organizational unit we've already created in Control Tower. If you've not created that OU, that's fine, you can create that. Right now we have no accounts there. These accounts we create that will be hosting, in our case, WordPress, will be created from a best practice and configurable template. That's because we use Control Tower and we'll be using Accounts Factory to create these. So these accounts will have guardrails in place. They could have custom VPCs, we could configure our own guardrails, and any changes to the AWS resources on that account will be logged in AWS config, and those logs will be forwarded to the log archive account, which sits within our foundational/security OU we already have, okay? So the question remains, well, how does that work in a multi-account environment? So as I mentioned already, we could have our workload accounts in the workloads OU, and we could have our own SCPs and guardrails applied to the OU itself to limit what the accounts in here can do. So we can limit certain AWS features we don't want our engineers or products to use. We can outright deny that through a guardrail at the top. And importantly, we can actually utilize services from these shared services. So if we manage our domain on the domains account, then any website we deploy here, the DNS records and settings will be managed by the hosted zone in the domains account. Earlier in the course, in part 5, we created a shared network account which has a VPC that's public, right? It has, I believe, 3 public subnets and 3 private subnets. So we can actually use these shared subnets in our workloads accounts. So we can host, say, WordPress on an EC2 instance and use the public subnets, right? Provided by the network account. We could also share the private subnets and deploy database solutions into there, or elastic file systems, or whatever we want to do. So we have that cross-account relationship there. So this course is called Getting Started. So we have a great foundation. But what are the next steps, okay? So if you were to grow your IT presence within your organization, what would the next steps be? Well, okay, so first off on my list I have CI/CD, which stands for continuous integration and continuous development. The idea here is we'll have what's called pipelines, which allow us to release our infrastructure or software to one or multiple environments, as well as do checks on the actual software itself. For example, we can start with the code, any custom application code we write. We can build that, so I'll compile that and run any tests on there. We can release that to a say a test AWS account, or release changes to like a sandbox or staging, verify that, and then we can click a button and deploy that up to production, and then we can automatically operate and monitor and plan for new changes and so on and so forth. So this becomes useful when we have a lot of different products and we have a lot of different environments. Automating the deployment of IT solutions makes sense. So that's going to be probably the next things you'll want to set up as you grow your IT team. On that note, it's just automation in general, and then we have infrastructure as code. Okay, so if you look here, you have what's called a CloudFormation template, and throughout the course so far what we've done is we've anything on AWS we need to make, we've made through the console, through the click and drag user interface, right? You can, however, use a structured text document, either a JSON file or YAML file, to define as a configuration file all the resources on AWS. So you could specify 2 or 3 EC2 instances, an S3 bucket, a directory, a VPC, some subnets. The beauty of this, having this as a configuration file, is it's reviewable, it's auditable, and it's fully configurable. So you can review this with other IT members to go back and forth to figure out whether it's in the right shape. We can validate this. You can create stack sets from this and test out their release to multiple environments. All the resources it creates is under a single stack, so you can easily delete that and it will delete all the resources, or recreate that from scratch just by releasing the template file. So that's infrastructure as code. In AWS that's called CloudFormation, and that's also going to be very useful for real world scenarios. If you prefer to do things in programming languages, and if you have a bunch of software engineers or developers, then they can use the Cloud Development Kit, which allows them to use their favorite programming languages to compile things into CloudFormation. So you can write higher level CloudFormation using the Cloud Development Kit. Going back to Control Tower, we can also use the Service Catalog API as well as the CloudFormation or the CDK to define and release multiple AWS accounts. Typically, you'll have a workload account per environment. So what you'll have is you'll have an account for each part of the software delivery lifecycle. So you could have a test account and then a live account for WordPress. You can do your changes on the test first, and real world users can't access this. And then you can, when you're happy with those changes, you can deploy them to live. Potentially, you'll have an account per environment. So what I mean by that is, let's say you have a test environment for WordPress. You may also have a WordPress deployments test in an AWS account where all the CI/CD and automation stuff lives, and you'll mirror that. You could mirror that per environment. So each workloads account will have a respective deployments account. Lots of different things you could do here. These are some of the extra steps for real world. I'd say these aren't needed, but as you're growing your IT presence, it does become incredibly helpful. So just keep that in mind if you're going to grow your IT team, that these are the kind of things you want to automate and get in place for best practice cloud environments. So on that note, I'll be keeping this course technically simple, and the WordPress demonstration will be technically simple as well. I want to demonstrate the most best practices with the least technical overhead for the lowest costs. That's the approach I've taken so far in this course. Now, with WordPress, this is not a WordPress course, okay? WordPress is just an example of a workload I can run on AWS, that you can run on AWS. WordPress, if you don't know, is software that you can run and manage yourself on a server, and it's software for essentially building a blog website, okay? So it will host your blog website, and you'll be able to see blog posts and whatnot, and you serve that through the internet to your average Joe Smith. But it also provides a admin login page where IT users can log in to the WordPress site and make administrative changes, so they can add new blog posts, change the theme, change the configuration under the hood, and all that stuff. So it's a full package website designing and hosting platform package, that's used massively worldwide and has been for years. I think something like 40% of websites go through WordPress or something like that, although that might be outdated. But architecturally, this is how it works. So the user hits your URL, your DNS name, into their browser. That resolves to a server, right? So an IP address through the internet, and that's running some sort of web server software like Apache or Nginx, which is then configured to talk to the WordPress software. So WordPress mediates with the underlying file system on the operating system to pull all its configuration and whatnot, as well as a SQL database to fetch data, so that we can return the full web page with all its blog posts and themes and whatnot back out to the web server, back out as a response, and back out to the web browser. So I guess there's 4 key components. So the web server, the WordPress software itself, the database, and what's not shown on here, but that's the file system of the operating system running WordPress. Every time you deploy WordPress, new configuration changes occur and changes to the database occur. Our implementation, however, will be simple. The simplest possible WordPress installation I could think of, which starts, if I get my pen. Okay, so it starts with the DNS, so that could be GoDaddy 123 Edge Route 53. And there'll be a record there pointing to a Elastic load balancer, an application load balancer. Okay, this can forward a request through to multiple availability zones. However, for simplicity's sake, we're going to host WordPress in a single availability zone on a single EC2 instance. This is going to have the WordPress software as well as the SQL database installed within the EC2 instance. So this is going to be able to scale vertically, which means we can add more CPU, more RAM, make this go bigger, but we can't deploy this across availability zone because the SQL database itself is installed on the EC2 instance, and so is the file system. So if we had multiple versions of WordPress in multiple availability zones, they'll all have different databases, and each with their own file system, so it won't be the same WordPress. So we're going to do a simple design that can scale up but can't scale sideways. Now, let's say you were actually to deploy WordPress and you do want to use AWS for WordPress. There are plenty of architectural next steps. So this specific design, this specific architecture, I've taken from Mick NG, from the AWS community builders. Great guy, seemingly. I don't know him, but he did a really good job with running WordPress on AWS. His architecture makes a lot of sense, and he shows a rather technical but very clean approach to deploying WordPress in a very scalable and cost-effective way. Okay, so I'll link his blog post down below so you can check that out, and you can also check out some of the reference architecture that AWS provides specifically for WordPress. But basically here, if I get my pen, my little highlighter, here you can see this is where the WordPress software and the web host software runs. So in our case we're using EC2, and in this case it uses ECS, that's Elastic Container Service. If you don't know what a container is, that's fine, don't worry. It's basically a lightweight portable application. So it's a container that runs an application as well as everything else that application needs. So you could have a WordPress container that has WordPress as well as Linux defined in it, everything that's needed for WordPress. It's got a smaller compute footprint than EC2, is much more portable, so it can be scaled up and scaled down a lot quicker than EC2 can, and it's stateless by design. So this is using ECS Fargate. Again, I'm not going to get into the details of what Fargate is and the different ECS options, but imagine this is some sort of compute layer, so it could be EC2. And on here is something running WordPress, and that can be scaled through an auto-scaling group to multiple availability zones, okay? Now, the issue with our current design, as I've mentioned, is everything's on one box. So the file system's on one box, the SQL database is on one box, so we can't really scale it horizontally, so sideways. So in this architecture, the first thing it tackles is the file system. So every time you deploy WordPress, it makes configuration changes and deploys different files to the file system on the OS. What we can do is use Elastic File System by AWS, which is a managed file system which you can mount from EC2 or ECS. Essentially, you can mount it to a computer and use that as a file system. So this would allow 2, 10, 20 different EC2 instances or containers running WordPress, all to be mounted on the same file system, which means they all share the same configuration. Same logic applies to the database. So in this situation, we don't actually have a database running within the compute layer. What we have is in this case, Aurora Serverless. Essentially, it's some sort of SQL solution by AWS. So typically you'd use AWS RDS, okay, and you'd have a managed database instance that'll have an endpoint, and you can configure WordPress for that database. This uses Aurora Serverless, which is basically RDS but in cluster mode, and it's better for horizontally scaling. And then we have also a bunch of the content that is stashed, right? So we have HTML, CSS, JavaScript, a lot of which doesn't often change. So what we can do is we can actually cache that in many different ways. We can cache it to simple storage service, and then serve that directly to the internet, or we can use something called CloudFront, which I'll explain in a minute. We can also use Elasticache and configure that with WordPress, so that it caches all this content to a dedicated cache provider. We could use CloudFront as well, which is basically it's Amazon's network of edge locations, which imagine it's one scale down from availability zone, little mini servers that, little mini data centers that are spread across the entire planet. What you can do is you can cache your static files like HTML, CSS, images, JavaScript files. You can cache that on the edge, which means it's actually deployed to many different locations globally. So that when a user comes in through DNS, be it Route 53 or whatever, they hit CloudFront first, and it checks if it has it in its cache. If it does, then it only needs to go to, say, let's say you're going to the website from Manchester or from Birmingham in the UK, okay? And let's say the server's running in Ireland. Well, there may be an edge location closer in, say, Bristol or whatever, where it will go to that instead of going all the way to your origin server. For security and SSL, use a certificate manager. You can use web application firewall as well to prevent certain attacks. You can use secrets manager to store secrets. Again, it's got an internal load balancer and external one, all this stuff that's meant to scale WordPress. You don't need all of this, but if you are going to run WordPress in production and start to scale that, the first two things you want to tackle are the file system and the database. Configure the WordPress, but be it in EC2 or whatever, to use a Elastic file system and mount to that, and then configure it to use a database provisioned in RDS. Everything else is extra, not necessarily needed to scale horizontally, but these two are the core things you need to tackle if you want to scale your WordPress site, or even really any or most web applications horizontally. Okay, decouple your database from your application code. And if you have any file system requirements, decouple the file system from the actual server running your software, so that you can run many of different servers running the same software with ease. So hopefully that made sense and wasn't too cerebral. Hopefully there's not too much information there. This walkthrough is going to be really simple. It's going to be slightly more technical than anything we've done so far, but it will be simple. So we'll start by creating a server. A server with WordPress installed. We'll verify we can talk to that server through its IP address to get to our WordPress homepage. We'll then bind that to our domain name, and then we'll secure that through an SSL certificate. So we'll have WordPress padlocked under our domain name, which for many people is all you really need. So let's get started, buckle in, let's do this. Okay, so welcome to the walkthrough. So we'll start, you can see on the SSO portal link, so the single sign-on web page, and we have, I've already created a WordPress account. You won't have that yet, but you can see our network account, our audit account, our management account, and whatnot. So if you've not created the WordPress account, go ahead and go through Account Factory and create a WordPress account like I have. Just log into the management console of the management account, and then you can go to Control Tower, account factory. Edit that. You don't need any VPC infrastructure deployed to that account. You can leave that blank. Go ahead and create your account and come back when that's created. Make sure it's in the Workloads OU as well. So come back and I'm going to log into the newly created account, the WordPress live account, which I called it. So first things first, we're going to want to create a EC2 instance. So this is the server that runs WordPress and everything WordPress. It's going to run the WordPress software and the database. So EC2, go to EC2 and go to launch instance. And we're actually going to select a Amazon machine image for WordPress. So in that search bar there, just type WordPress and hit enter. And it should take a while to load. Go to the marketplace AMIs. And at the top of the list, you should see the WordPress certified by Bitnami and Automatic. Select that one, because that's typically like a best practice setup for single instance WordPress. So select that and name your server. I'm going to keep my name simple. Let's call it Acme Corp WordPress example. Okay, so instance type is set as small. That's the vertical scaling we talked about. We don't want to create a key pair. So if you wanted to log into this server to administer the file system or WordPress or whatever, we'd log in through SSH and we'd use this key pair. So create that, and that's going to download that to your machine. Just save that somewhere safe. Okay, so now we can edit the network settings. So we want it in the shared VPC for my network account. And for the subnet, just choose one that's a public subnet. So it hasn't got the names here, so if you need to get those names, go back to your network account and list on those subnets, but I've selected one in availability zone A. You can leave all these default settings as they are. I mean, you could limit the SSH to just your IP address if you wanted to, but it's not major. Again, no other settings need to change there. And in advanced details, you can choose a instance profile or create a profile to run the instance under. I didn't find that necessary. It's not needed. So you can leave that blank if you want. Review all those settings, and when you're happy with that, you can launch the instance. But essentially all we did is edited network settings and gave it a name and created a key pair. So launch that instance, and we're going to want to wait until it's in the running state, so the available state, and both the status checks are passed. If you followed along with part 5 of this course, you will have experience with EC2, but if not, don't be scared. It's not that bad. So you can see here it's running, but the status check is still initializing. So just come back when that's done. Okay, so our instance is running and both our status checks are passed. So we copy the public IPv4 address there in details and paste that into our browser. It may take a while at first, might be slow, but you can see there is our WordPress site. Okay, so it's got an example blog post, which is the default one. And if we go in the URL and put wp-admin, we can get to the login page for the administrator. The username is going to be user, but we need to get the password, okay? So one way we can get this is head over back to EC2. Under your instance, drop down Actions, Monitor and Troubleshoot, and Get System Log. We should see a full system log here, and if we search this, just Control F, password, and go down, we can see the password. Now don't try using this or connect into my instance, because it's going to be long destroyed before all this is uploaded to the internet. But paste that password into your wp-admin page and log in. So this is going to try and log in to the administrator page. It might take a while, might be a bit slow. I've noticed this especially on the single instance mode where it can be like very slow to get started. But what we can do for now is we can go to GoDaddy, or wherever your DNS is managed, could be the Route 53 in the domains account. And what we want to do is we can get that IP address, and we can create a domain record for www. Our domain to go to our IP address, our EC2 instance. So what we need to do is go to add. That needs to be a well, firstly make sure you delete any www CNAMEs you have already. We already have one there, so this is not going to add, it's going to validate. So what we want to do is we want to delete the CNAME record we already have for our site. So I've deleted that. So we already had a CNAME for www. So what we can do now is add an A record. Now we've deleted that, www, and paste our IP address in to the value. And now what it's going to do is update our DNS record. So now www.ourdomain.com actually just points to the IP address of our EC2 instance. Now it may take a while for those routes to propagate, so it may take up to a few hours. So don't worry, just come back when that is updated and you'll be able to see your site. So whilst we wait for that DNS record to propagate and for our site to be available, what we can do here is I can just show you that the WordPress site has loaded now finally as admin, and we can add a new post. So if we go and add a new post, do something like foo bar or some gubbins and just publish that, publish again. Now if we just go to the homepage of our website, same browser, you can see that, but you can also see that we're still logged in. So what would an actual user see? Well, we can log out and go back to that website, the IP address. We can see our new blog post is there. Okay, so what we can do now is we can prepare for actually securing our site, because you can see it's still HTTP. So if you go to that website here, just refresh that. Okay, let's wait until that's finished and that's ready. Okay, here we are. You can now see the site is loaded with our domain name. Although as mentioned just now, it's still not secure, it's HTTP only. So how do we go about actually securing that behind an SSL certificate? Also you can see navigating to WP admin is still a bit slow. It's still working on that, but at least you can see that the site and domain name are registered. So what we can do is we can create a load balancer. So this is piece of network. Our session's expired. Let's just go back to there. Okay, so a load balancer is a piece of network infrastructure attached to a VPC that has a public DNS name, and it can route requests to many different instances. So it could, for example, route that to 3 or 4 different EC2 instances all running WordPress. We're just going to have the one instance as mentioned, but we're using a load balancer because it's very easy to integrate that with a certificate, an SSL certificate through ACM. So go to load balancers and select application load balancer, because that's for HTTP and HTTPS, and give it a name. So again, we're going to create this load balancer. It's going to have a target group of HTTP and HTTPS for our instance. So one target group and 2 listeners, one for HTTP and one for HTTPS, and HTTPS is going to be attached to an ACM certificate. So select IPv4, select our VPC, and you can tick all these and make sure they're all public subnets. So I know which subnets are public and which ones are private just by recognizing the name, but you can tell based on that message there. And these subnets come from the network account again. But if you drop those down, you can see that message goes away if that subnet has a route to an internet gateway. So I know all those 3 are public. If I go back, there you go. That's not public, it's private, that's public. So, okay, we need a security group. So, really simple. It's just going to allow all traffic through. We can give that a name, something like WordPress, load balancer, security group. Attached to our VPC, yep. No inbound rules. One simple outbound rule, all traffic just through. I think we need a description. We need a description for that. So we can just call it something like security group for WordPress, load balancer. Click create security group. Okay, go back to the journey and just refresh that, and you can now select that security group. Okay, so this is what it talks about. So this listener is HTTP traffic, and and I'm going to have a second listener for HTTPS. And each one of those is going to need a target group. So first I'm just going to change it to HTTPS, which changes the part by default. Okay, so what we can do now is we have our HTTP listener and we have our HTTPS listener, is we need to create a target group for each. Okay, so we'll create a target group for one. I'm just going to open up 2 links, so one for each. So we'll do our HTTP one first. So it's for instances. It's a target group for EC2 instances. The name can be something like WordPress, load balancer, target group, HTTP. Okay, so the VPC selected, yep. HTTP one, yep. Health checks, yep. That's fine. No changes there. Click next. Okay, so we can select our available instance, which is our WordPress instance. In that availability zone, select that and include it as pending below. So, yeah, just click, and click including as pending below. Check all that, make sure that's okay, and then create that target group. Okay, so that's going to create that target group now. So we now have a HTTP listener target group for our EC2 instance running WordPress. Now for the HTTPS one. So again, instances, WordPress, load balancer, target group, HTTPS. So VPC, yep, HTTP one, yep. Click next. Select our instance. Include as pending. And create. Okay, so we now have our 2 target groups. Let's go back to our load balancer journey and we can refresh both of those. So choose the HTTPS one for HTTPS and the HTTP target group for HTTP. Now we're going to need, because we have a HTTPS listener, we need to specify the secure listener settings. So we need an Amazon certificate, a certificate for our listener. So we're going to request one from Amazon Certificate Manager. And we can also change the policy, but I just like to leave it as default, but you could make that latest, I guess, but I'm not changing it there. So again, from ACM, let's request a new ACM certificate. So we're basically requesting a free SSL certificate for our site, SSL/TLS certificate. So let's, if you scroll down and try and create this load balancer, it won't work because we need that certificate. So again, leave that as from ACM. Get your security policy to be what you want it to be, and head over to Amazon Certificate Manager. I already have one here requested, but ignore that. And again, making sure the region is correct, just click request for your certificate. And we're going to request a public certificate. Click next. Now, the domain name needs to be the domain name you're going to use. So you can actually have multiple names here, but in my case, it is going to be a company making everything.co.uk. Okay, so leave it as DNS validation and click request. So that's now pending validation, as you can see here. I have 2, so I'm just going to, I'll delete the one I don't need, so it won't be confusing. Which one is it? Yeah, that one. Okay, so we're going to need to validate this. So what you can see is it's still not there because we can only select validated certificates. So what we need to do is, you can see it's pending validation. If you click into that certificate, you see there is some records here, DNS records. So what you need to do is go to your domain provider and add these records in, these 2 records. So they're both CNAME records, and that tells ACM, Amazon Certificate Manager, that you actually do manage that domain. You have the rights to own that domain. So that's, say, 1 record, sorry. Paste that in, and now we need to wait for it to validate. So come back when that's valid. Okay, so it's valid. So we can refresh that now and select that certificate for our load balancer. Okay, so what we can do is just review this configuration. So certificate from ACM, map to all public subnets, 2 listeners, 1 instance, 1 target group. So 2 target groups, 1 instance. Yep, okay. So let's create that load balancer now. So we can view that load balancer if we wished. And if you click view load balancer, there you can see the load balancer. So it's still provisioning, it's still in the provisioning state. So we'll come back when that's fully provisioned and all ready to use. Okay, so now that that's provisioned, it's fully active. what we can do is we can copy the load balancer DNS name, copy it from there or from the bottom in the description. And now we want to change our record in our DNS settings. So I have it as an A record now, pointing to the IP. I want to change that to the DNS name of a load balancer. And then, okay, so we need that to be a CNAME record. So drop the type down. As you can see, it needs to be an IP address. So change that to a CNAME. And then just check that, yep, and then hit save. Okay, so that's now updating. And now our domain name will point to the load balancer, which is secured behind an SSL certificate, which will then point to the IP address of our EC2 instance. So that's going to knock out the DNS. So wait for that to come back online for those records to propagate, and we should have a secured domain name. Okay, so one thing that I did forget is to add an inbound rule to the security groups. So if you go back to EC2, because right now it's security groups denied by default, so right now no traffic is allowed through from our load balancer. So go to security groups, find your security group and edit the inbound rules. Okay, so we're going to want HTTP for IPv4 and IPv6 to be allowed through from anywhere, and the same with HTTPS. So HTTP port 80 anywhere IPv4, HTTPS anywhere IPv4. As you can see, that changes it, so we need an extra one for HTTP again. HTTP anywhere IPv6, and then HTTPS. Anywhere IPv6. Okay, so now our load balancers should allow any inbound traffic to the load balancer. So we can see that if you go to target groups, load balancers, and then listeners, and scroll down, you can see there's no little yellow triangle, which was there previously because it wasn't allowing any traffic. So now HTTP and HTTPS can go through. And then lastly, when we registered our SSL certificate through ACM, we actually made it so that it only is for the actual domain, no subdomains, no www. So right now that won't work for HTTPS. So let's request a new certificate from ACM, and we'll do star dot the domain name. Then we can add another name. And now again, this process of adding domains and whatnot, adding certificates, I mean, if you don't do wildcards, you will need to do this for pretty much every new subdomain you use, but I'm using a wildcard here. So I've got both of those names, WildStar and by itself. DNS validation, same process. Okay, so we go to GoDaddy, and we add the rule. So we can edit that. And save those values. Now if we go to the certificates, what we can see is both those names. I need the wildcard one to be in use. So you already have those values applied. Let's just double check those, make sure that's right. And those are identical CNAME values, so you don't need to do distinct ones for each. Just definitely make sure they're applied. Let's see if this will let us add that. It shouldn't let us add it because we've already created it. Yep, that's fine. So what we need to do is we need to make the new certificate in use. So go back to ACM, go back to load balancer, sorry. Where am I? Okay, cancel out of that. Nope, that's not what we need. Okay, go back to the listener, edit that. Okay, now we can change the certificate. That was weird. So go to the bottom and then drop that star.domain name. Okay, save those changes, and that should apply pretty instantly. It's just an Amazon change, not so much a DNS change, and we can see they're in use. both validated. You can see it's using the new certificate. If you go to the list of rules, go to certificates. Okay, so now what we can do is we can test out our website. So just paste the domain name into the browser. Just copy that from GoDaddy. Paste that. Enter, and you see it's padlocked. So we have a WordPress site pointing to EC2 on our domain. And that's basically it. So we've created a simple, very simple, I wouldn't say necessarily production ready, but a simple WordPress website as an example of a workload. So what we've done is we've completely set up an AWS account and an AWS organization from scratch using best practices and fully secured. We've demonstrated how to invite users to AWS and delegate access, as well as delegate access to other applications you may need in your organization, as well as providing mail services and desktop services, and then actually running a public-facing internet-accessible workload on AWS, secured behind an SSL certificate and balanced by a load balancer. So that's that, and thank you for your time. I hope this has been useful. Again, this hasn't been super technical, but I hope you've got what you need. Thank you, and until the next one, don't forget to be awesome.